Problem solving lecture, we will talk about motion and mixture problems. Let's look at the first example. This example says that a plane has 7 hours to reach a target and come back to base. So it flies out to the target at 480 miles per hour and returns on the same route at 640 miles per hour. Ask us how many miles from the base is the target. We assume this is the base, and then target is right here. So based on the question that a plane has 7 hours to reach a target from here to here, and then come back, and then come back to base. So if you assume the time from the base to reach the target is t, based on the first sentence, you will see a plane has 7 hours to reach a target and come back to base. So if reaching the target is t, then the total time is 7 hours. From the target to the base would be 7 minus t. So we figured out the information from the first sentence. The second sentence said that it flies out to the target at 480 miles per hour. So from the base to the target is 480 miles per hour. And then returns to the base with the speed 640 miles per hour. From the target comes back to the base is 640 miles per hour. We know this is like from the base to the target, and then from the target to the base. So with the different speeds or the rates, the distance is the same. Because of the speeds or the rates are different, so the time might be different from the base to the target and from the target to the base. But we know the speed going from the base to the target is 480. And then time is t. We know speed times time is the distance. You know, when you drive the car, like speed is 70 miles per hour, then 2 hours later, you know that would be 140. So it's because 2 times 70. Right here, the speed is 480 miles. The time is the time you don't know, but you do know 480 times t is the distance from the base to the target. Going back, the distance is the same. The speed is not the same, it's 640. The time is 7 hours minus t. But we do know, again, the distance equals 640 times 7 minus t. So we do know that 640 times 7 minus t is the distance, the same distance from the base 480 times t to the target. From the base to the target That's 480 times t. Since we have this equation, then we can solve for t. How to solve that? Distributive property says that 640 times 7 then minus 640 times t. So you have 640t minus. Now both sides add 640t, you cancel positive negative, 640t. Then you have a 640t plus 480t, that's 1120t, left hand side. Right hand side is 640 times 7, gives us 4,480. So both sides divided by 1120. Then we have a t is 4. So this t actually is 4 hours. Okay? Now we know t is 4 hours. Going from the base to the target is 4 hours. We know the speed is 480 miles. Then, of course, the distance would be 480 times t, which then gives us 1920 miles. Okay, 1920 miles. That's the solution. All right. Now, try yourself. This one is similar. A man left home driving at 40 miles per hour. When his car broke down, and then he walked home at a rate of 5 miles per hour. Now, the entire trip, driving and working, took him 2 hours and a quarter hours. How far from his house did his car break down? So this question is similar to the one above. Okay? From the home to the place where the car broke down, the distance when the car broke down, and then this person walked home. So the distance is the same. The car drives faster, 40 miles per hour, going back 5 miles per hour. Walk home. Walk home. So here we know the total time for driving and working is 2 1/4 hours. So if you assume driving from home to the place where the car broke down is t, then you have the total time minus t would be the time from the place where the car broke down to the place where his home was. Okay? So from here you can see you have a 40 times t, 40 miles per hour times t, you have the distance. And then 5 miles per hour times 2 1/4 hours minus t would be the distance again. Then the distance are equal, so you will have a 40 times t equals 5 times quantity, 2 1/4 hours minus t. The final answer is 10 miles. Try yourself. Similar to the one above. Now, let's look at the mixture problem. This problem says that how many liters of a 40 glycerin solution must be mixed. You have 2 mixed. So must be mixed with 10 liters of 80 glycerin solution to obtain a 65% solution. Now, let's see. First of all, we need to note that the amount of glycerin in a liquid equals the amount of liquid times the concentration. Okay? So the glycerin inside that liquid is actually equals the amount of liquid, well, more liquid than times the percentage. Okay, the percentage. This percentage normally is less than 1 or less than 100%. Okay? So this concentration times the liquid would be the amount of glycerin. Okay? Would be the amount of glycerin. Now look, how many different kinds of glycerin solutions do we have? We have at the beginning 40% glycerin solution. So 40% mixed with 10 liters of 80% glycerin solution. So we have 80%. Eventually, we want to obtain a 65% solution. So we need a 65% solution right here. So we have 3 kinds of concentrations. What is the amount of this liquid for 40% concentration? This is what we want. How many liters of 40% glycerin solution must be mixed? We don't know. So we assume this is X. But we do know the amount of glycerin must be mixed with 10 liters of 80% glycerin solution. So 80% glycerin solution has 10 liters. Has 10 liters. Okay. Now, 40% is X liters, 80% is 10 liters. If you mix those two together, total is how many liters? So it has to be X plus 10 together. Okay? X plus 10 together. Now, so for 65% solution, we know the amount would be 10 plus X. Okay? You put 1 cup with 40% liquid. The amount is X. Another cup is 80%. The amount is 10 liters. So you put together, then you have the amount of liquid would be 10 plus X. That's the amount of liquid. And eventually the requirement for this resolution is 65%. Okay? 65%. So, we know at the beginning the amount of glycerin equals the amount of liquid times concentration right there. Right here, 40% glycerin times the amount of liquid, which we are going to find out, is the amount of glycerin. And 80% glycerin solution times 10 liters would be the amount of glycerin. Now, the final requirement of the glycerin solution is 65%. 65% times 10 plus X, that's the amount of liquid. So it's the whole quantity times 0.65. 65% is 0.65. Okay, 0.65 times 10 plus X with the parentheses. We know you add 2 liquid together, the amount of liquid is 10 plus X, then the amount of glycerin is actually the glycerin in 40% solution and the glycerin in 80% solution add together. So basically those two add together should be equal to the glycerin in the last cup. So this would be 0.4 times X, you get the amount of glycerin from 40% solution. 0.8 times 10, you will get the second the amount of glycerin. So you add one cup, the glycerin from the first cup plus the glycerin from the second part together should be equal to the glycerin in the last cup. That would be 0.65 times the quantity right here. So those two amounts should be equal to each other. Again, by distributive property, 0.65 times 10 plus 0.65 times x. So you will get 6.5 plus 0.65x. The left-hand side, you have a 0.4x here, and then 0.8 times 10, you have 8. Both sides minus 0.4x. Right here is positive, negative 0.4 cancelled, 0.4x cancelled. Then you have 8 on the left-hand side. Right-hand side, it has 6.5 plus 0.65 minus 0.4, you have a 0.25x. Okay? Here we have x, you take it. Now both sides minus 6.5, 6.5. 8 minus 6.5 is 1.5. And then positive, negative 6.5 cancel each other, you have a 0.25. So 0.25x equals 1.5. And then both sides divided by 0.25. You have a 0.25 upstairs and downstairs cancel each other. And 1.5 divided by 0.25, which is 6. So x equals 6 liters is the final answer. Now, try yourself. How many parts of glacial acetic acid? So here is the concentration, 99.5 acetic acid. Must be added to 100 parts of 10% solution of acetic acid to give 28% solution. This question is similar to the one right here. We are going to assume the amount, how many parts of the glycerin. So we will assume how many parts? Let's say x. Okay? Let's say x. So then we have a 99.5% acetic acid. The amount of the liquid, the amount of parts is x. Now, here 10% solution of acetic acid, the parts is 100%, 100 parts. So you want to put right here. Okay, 10% corresponds to 100 parts. Now, 28%, the amount of glacial acetic acid, this is the number of parts, because those two together is x plus 100. So it's like the one right here, x plus 10 is the one right here. And then we have 3 kinds of concentrations. Previously, we have those two add together equals the last one. Here is the same. So the first two together equals the last one, 0.28 plus times x plus 100. Those two together should be equal to the last one. The answer is 25 parts. Okay? Study those two examples and try more different ones, and probably you will get this part. Okay? I'll see you in next lecture.